In this tutorial, we're going to start looking at Slippery Chicken in conjunction with Common Lisp Music, or CLM. So first of all, we'll cover the basics, what it does and how it works, how to set the output directory for the sound files that we'll produce, what's a sound file palette, what the sound file groups are in this sound file palette, and how to call clm-play in its simplest fashion. So first of all, let's talk about creating sound files from the data of Slippery Chicken objects. What we're doing with the call to clm-play, when we get to that, is to create a new sound file for one or more players' parts. So this uses the rhythms and certain aspects of the pitch material for each of those players' parts to produce a sound file using one or more source sound files or samples as input. The first thing we'll see in the call to make Slippery Chicken, the function, is that we'll set the sound output directory. And this can be any directory of your choosing, but we'll use the /tmp directory first of all. The sound file palette is a list of source sound files which is grouped in sublists. And these sublists contain groups which are to be used in a single call to clm-play. So clm-play can only ever use one of these sound file groups unless you want to transition between two groups, which we'll talk about later on. So when we create the sound file palette, we're creating a list of groups followed by a list of the paths where the sound files are to be found and the sound file extensions, .wav, .aiff, or whatever your sound files happen to be. So in this sound file palette, we can see that we've got a first group called Percussive Models Group, and it consists of three sound files called source sound file 1, source sound file 2, and source sound file 3. So these will be cycled through when we call clm-play. We've also got another group called sustained pads group, also with three sound files. And then we've got the paths to those sound files. So these are the directories where those sound files live, where we will search for those sound files, as well as the simple extension AIF, because all of these files are AIFF files. The simplest call to clm-play would take the first argument of the Slippery Chicken object, the second argument of the ID of the starting section in the Slippery Chicken object, and then further arguments of the IDs of the players whose events will be the basis for the new sound file, and the ID of the sound file group that we'll use when using the data of those players' notes. So you can see our first call to clm-play here uses arguments of the SC object, the Slippery Chicken object, section 1, the flute and oboe parts, and using the sound file group 1. If the player IDs, that's the third argument to clm-play, is nil, then the event data will be drawn from all players. So every player in the piece for that section will be used to create the output sound file. So you can see a call here to clm-play with nil as the list of players. You can see in this example here that we're setting up a Slippery Chicken structure with our sound output diode. This is the first time we've seen this, and the sound file palette as well, as just discussed. And you can see the call to clm-play and hear how that would then sound.